Introduction. According to a generalized degeneration of the brain, Alzheimer's disease is an irrevocable brain disease leading to progressive mental decline and can strike at any age. Alzheimer's disease is uncertain when it is first developing. The project's goal is to identify people who might have Alzheimer's. Early diagnosis facilitates educating about dementia, reasonable expectation setting up, and future preparation for the person with it and guardians. Problem statement. Alzheimer's disease is a brain disease that gradually decreases thinking, memory, and the capacity to perform even the most basic tasks. Early detection of Alzheimer's disease opens up more clinical trial options for patients and gives caregivers more time to adapt to the functional, psychological, and personality changes that might characterize the disease and changing perspective from a caregiver position. The project aims to enhance the ability of the model to differentiate between people with Alzheimer's disease dementia and those without the disease at the earlier stage. Summary of LR. Methodology. Purpose and feature. Clearly outline the purpose of the Alzheimer's disease detection, emphasizing features like early detection, monitoring, and support for patients. This specify how deep learning will be integrated to improve diagnostic accuracy and efficiency. Data collection. Gather a diverse and extensive dataset of brain imaging scans, including MRI and CT scans, from individuals with and without Alzheimer's disease. Collaborate with medical professionals and institutions to ensure the dataset's authenticity and relevance. Data preprocessing. Implement preprocessing techniques to clean and standardize the imaging data. Consider techniques like normalization and augmentation to enhance the model's robustness. Model development. Design a deep learning model suitable for Alzheimer's disease detection, considering architectures like convolutional neural networks, CNNs, for image analysis. Split the dataset into training, validation, and testing sets for model training and evaluation. Model training. During model training, the system utilizes preprocessed MRI scan images to train a CNN and RNN. The training process, possibly by observing the training loss and accuracy. Validation and testing. To keep from overfitting, validate the predictive model on the validation set and then test the final product on a different testing set to see how well it expands to new data. Continuous improvement. Establish structures to support ongoing learning and development, takes account of frequent updates based on current data and research. You can develop to recognize Alzheimer's disease with the additional complexity of deep learning integration by using this updated methodology. Architecture diagram. Algorithms used. Using deep learning to detect Alzheimer's disease calls for evaluating sequential data, mainly time series data from brain imaging scans. Convolutional neural networks, CNNs, and recurrent neural networks, RNNs, are frequently employed designs for this type of programs. Processing 3D imaging of the brain data, such as MRI examinations, which had been preprocessed by scaling and normalizing for consistency, is the initial stage in using the CNN model. After that, feature extraction is carried out using convolutional layers to identify spatial structure and pattern associated with Alzheimer's disease. Sequential data displaying changes over time is processed by an RNN model. Preprocessing of the input, because frequently depicts successive changes in activity in the brain, includes handling missing data and normalization. Ensemble methods integrating predictions from both CNN and RNN models are investigated for possible better performance in model integration and evaluation. To evaluate the resilience and generalization of the examples, cross-validation is used. Metrics including accuracy, recall, F1 score, accuracy, and the region of the ROC curve are used. Implementation. Time distributed. Model equals 2D, filters equals 1, activation equals 128, underscore size equals, or normal. Onva 2D, kernel underscore initial equals 2, 2. Hash add simple RNN layer model.add, initializer equals, model.add, sparse underscore cat, summary. Predicted values. And recurrent neural network, RNN, architecture for the early detection of Alzheimer's disease from brain MRI images. The CNN and RNN model is more suitable for image processing, especially in image classification, and has shown higher accuracy in predicting Alzheimer's disease-affected brain versus a normal aging brain. The use of advanced neuroimaging techniques, such as MRI, allows for the extraction of shape features and texture from the hippocampus region, aiding in the detection of Alzheimer's disease. References. Reference. Ballard C. Dion Science. Computational. Hinton Reference. 5. Classification in multi-centered and computation of statistical information technology and 20114 applied optimization. MRI brain using support vector machines.